Here in this section, we have combinations of functions, composite functions. So the first part is about domain and range. When a function is given as a set of ordered pairs, the domain is the set of all first coordinates, and range is the set of all second coordinates. Example, find the domain and range for the function f given by set. We have ordered pairs 2, 0, -1, 5, 8, 0, -3, 2. So domain is set of all first coordinates. So I have 2, -1, 8, -3. And then closed set. Range is set of all second coordinates. So here we have 0, 5, 0, 2. So 0, 5. I'm not going to repeat, so I'm not going to rewrite 0. So this is our answer for range. Domain of a function as an equation. The domain of a function represents all x values for which the function can be computed. Avoid any values which will make a function undefined, including making the denominator of a function equal to 0. Example, find the domain of f. So here on the spot, number 1, f of x is equal to 5 divided by x minus 4. We shouldn't have undefined, meaning that our denominator shouldn't be 0. So x minus 4 equal to 0. X is 4. Based on what we have here, finding domain. As x such that x is all real numbers, or I can write x belongs to all real numbers except 4. So we cannot have 4 in our domain, because if I have 4 here, 4 minus 4, that part will be 0, and 5 divided by 0 is undefined. But this is our domain, or we can write this way: from negative infinite to positive 4, use parentheses, union 4, positive infinite. When we have negative infinite, positive infinite, we always have parentheses, and because we cannot have 0 in denominator, x is not equal to 4, so here on this part we didn't use brackets, so we use parentheses to show that x is not equal to 4. Number 2, 5 divided by x squared minus 9. So again, same thing, finding x. Here x squared minus 9, that is x minus 3 times x plus 3 equal to 0. X is 3 and negative 3. So when finding domain is x such that x belongs to all real numbers except 3 and negative 3. Close set. So this is set builder notation. that was same for this one. So this one was set builder notation. And this one was interval notation. Now here on this part, domain. So on top I did set builder notation, and this one is interval notation. So we have negative infinite to negative 3, union, negative 3, positive 3, union, positive 3, infinite. So this one is interval notation. Number 3, f of x equals to absolute value of 6 minus x. Here in this case we do not have denominator. Denominator is 1, so we don't have any variable in denominator. So we're not going to have undefined. So for this reason we don't need to find what we did in number 1 and 2. So based on that, because of not having denominator, our domain is all real numbers. So x such that x belongs to all real numbers, or we can write this way using interval notation as negative infinite, positive infinite. Number 4, f of x equal to x squared plus 3 times x. Here again, our denominator is 1. We don't have any variable in denominator. So again, we have same answer. Domain is x such that x belongs to all real numbers. So I'm using x because here we have x. In this part again, we had x, and that was because we had x here in our input. So domain, again, negative infinite, positive infinite. Number 5, our function equal to square root of 9x minus 27. Now here in this case we have square root. So use what we have inside, square root 9x minus 27. Whenever you had square root, you should have greater than equal to 0. And then solve for x. So I added 27 to both sides first, and then divided by 9 both sides. So x is greater than equal to 3. So based on this, domain is bracket 3 comma positive infinite, because this is what we had here on this part, x it was greater than equal to 3. And then in set builder notation, our domain is x such that x greater than equal to 3. Number 6, our function is equal to 5x divided by square root of 24 minus 3x. Here again we have square root, but this one is in denominator. And denominator we cannot have equal to 0. So 24 minus 3x greater than 0. Solving for x. I added 3x to both sides, and now divide by 3 to isolate x. 8 greater than x or x less than 8. The domain is negative infinite, comma 8, because here we have x less than 8. Or writing this way, domain is set x such that x less than 8. The algebra of functions, here we have sum, difference, product, or quotient of two functions. If f and g are functions and x is in the domain of both functions, then f plus g of x is equal to f of x plus g of x. And here we have f minus g of x is equal to f of x minus g of x. F times g of x is equal to f of x times g of x. And finally, f divided by g of x is equal to f of x divided by g of x. And because of having g of x in denominator, g of x is not equal to 0, because if we had 0 in denominator, we're going to have undefined. So this part denominator is not equal to 0. The domain of the combination is the intersection of the two individual domains, meaning you must go with the most restrictive domain of the two original functions. If f divided by g can be simplified, determine the domain before simplifying. Example for f of x equal to 5 minus x squared and g of x equal to x squared plus 4x minus 12. Find part A, f plus g of 4. So this is equal to f of 4 plus g of 4. So this is equal to, using this function f, instead of x, we have to use 4. This is equal to 5 minus 4 squared. And plus g of 4, use g of x, and instead of x, use 4. So we have 4 squared plus 4 times 4 minus 12. So this is equal to 5 minus 16 plus 4 squared is 16. 4 times 4 is 16 minus 12. So here we have negative 11 plus 20. So the answer is 9. Part B, f minus g of x and f minus g of negative 1. So first finding f minus g of x. That is equal to f of x minus g of x. And here we have 5 minus x squared minus g of x is x squared plus 4x minus 12. So here we have 5 minus x squared. Use distributive property and multiply negative by x squared. Negative times 4x. Negative times negative 12. So here we have combined like terms, negative x squared, so we have negative 2x squared minus 4x plus 17. So we have this one for f minus g of x. Now finding f minus g of negative 1. So use f minus g of x, and instead of x, use negative 1. So we have negative 2 times negative 1 squared minus 4 times negative 1 plus 17. So negative 2 times negative 1 squared is 1. So here we have negative 2. Negative 4 times negative 1, we have positive 4. Then plus 17. So answer is 19. Part C, f divided by g of x and f divided by g of negative 4. So first finding f divided by g of x, and that is equal to f of x divided by g of x equal to 5 minus x squared divided by x squared plus 4x minus 12. And now finding f divided by g of negative 4, that is equal to 5 minus negative 4 squared divided by negative 4 squared plus 4 times negative 4 minus 12. So on top we have 5 minus 16, and that is negative 11. Denominator we have 16 minus 16 minus 12. So we have negative 12. So the final answer is 11 divided by 12. Part D, f times g of 4. So this is equal to f of 4 times g of 4. So this is equal to f of 4 is equal to negative 11 from part A. So in part A we had f of 4 plus g of 4. So we have the answers for these two. I'm going to use that part. Negative 11 times g of 4 is 20. If in case these were not given, or if in case you didn't find that, for example, here in part A, we can find by using 4 instead of x in f of x and 4 instead of x in g of x. So exactly same as what we did here on this part. So the answer is negative 220. Number 2, for f of x equal to x squared minus 12 and g of x equal to 9 minus x, find f plus g of a. So this is equal to f of a plus g of a. So instead of x, now we have to use a. We have a squared minus 12 plus 9 minus a. Combine like terms, we have a squared minus a. Negative 12 plus 9 is negative 3. So the answer for this part is a squared minus a minus 3. Part B, f of 10 divided by g of 10. So use 10 instead for x. We have 10 squared minus 12 divided by 9 minus 10. So this is equal to 100 minus 12 is 88, and denominator 9 minus 10 is negative 1. So our final answer for this part is negative 88.